How's it going, you guys? So for this video, we're going to go over the problem +1. This is an array problem that's asked at Google. So the description says, given a non-empty array of digits representing a non-negative integer, +1 to the integer. The digits are stored such that the most significant digit is at the head of the list, and each element in the array contains a single digit. You may assume the integer does not contain any leading 0 except the number 0 itself. So in the first example, we're given an input array containing the numbers 1, 2, and 3, and we just need to +1 to this array. So 1, 2, 3 in our array is represented as 123, right? And so our output should be 124, but just broken up. So for every index, it's going to be a single digit, right? So I'll jump over to the whiteboard and I'll walk through an example. Let's say we had the array containing the numbers 8, 9, 9, and we need to add 1 to this array. So 899 plus 1 would be 900, right? So what we need to do is we need to iterate from the back of our array, the end, to the front. And we need to check if our number is less than 9. If it's less than 9, then we can just increase that value by 1 and then immediately return from our function. However, if the number is a 9, like in these two examples, we need to move to the left and then check the next digit, right? So we would iterate starting at the end, right? So we're at number 9. And since this is a number 9, we need to change this value to a 0. So this will become 0, right? And then we're going to continue iterating. And we're going to keep doing this check until we exhaust looking through all of the numbers in our array, or we find a number that's less than 9 that we can just increase by 1. So we have another number 9. So this would change to 0. And then we iterate once more. But now this number 8 is less than 9. So all we need to do is plus this 8 by 1, right? So we would overwrite this position to 9. And that's it. And so this would be our final result that we would return from our function. So there's one more edge case that we have to consider. Imagine that we had the array, say, 9, 9, 9, right? If we were to +1 this, we would get 1,000. So if we were to go through from back to front like we did, we look at this number 9, this number 9, and this number 9, right? That means all of these numbers would be changed to zeros, right? So that would change to a 0, that would change to a 0, and that would change to a 0. But we still need to add 1 to this array, right? So we just have to have an extra edge case. If we make it through this for loop without returning from our function, we know that we need to add a 1 to the very start of our array. So let's jump over to the code and I'll show you guys what this looks like. So we're given an array of digits and we need to return an integer array representing our new number that's just +1, right? So the first thing we can do, let's just extract the length from our digits just to make our lives a little bit easier, right? And so now we need to iterate from the back to the front, right? So we can say for int I starting at n-1, right? And we're going to go until this is less than or equal to 0, or greater than equal to 0, right? And when we're in this for loop, we need to check if our number is less than 9. If our number is less than 9, we just need to increase that position by 1, and then we can immediately return from our function. So we can say if digits at index I is less than 9, then increase that position by 1 and just return digits, right? because if any number was less than 9, we increased that 1, that means we're finished. And then if this does not occur, if we don't make it in this if statement, then we need to set digits at index I to 0, because we know at this point this must be a number 9, right? So after this for loop, if we make it outside of here, this is where our edge case comes in. If we make it to the end here, we know that we had all 9s in our digits array. So if we make it here, we know we had all 9s. And so in that case, we need to allocate new memory and create a new array of digits. So we can say int our new digits, and it's going to be size of our original digits array, just +1, right? Because we need to add that extra number 1 in the beginning. So we can say n plus 1, and we can say new digits at index 0 is equal to 1, and then we'll just return new digits, right? So the reason why we only have to set the very first index is because when you create the array, by default, everything is initialized to 0. And so we just need to assign the very first index as 1. So let's just make sure that this code works. Cool. And so next, I'm going to go into the time and space complexity. The time complexity of our solution is going to be big O of n, where n is the number of digits that we have in our array. In the worst case, we have to iterate over every single digit, right? And then our space complexity is also big O of n. In our edge case that we do on line 20, this is where our extra space comes from. Because if we have all 9s in our original digits array, then we have to allocate new memory, specifically n plus 1, where n is the size of our old array, right? So that's it for this video. Thank you so much for watching, guys. I'll see you guys in the next one.